test. Oh, God. So we will just sort of do this old action. Oh, yeah, yeah. Okay, this is so weird.
Yeah, it's wonky.
All right, everyone, give it up for Enzo and Asa for NTLM relaying. Woo!
Alrighty, we're gonna get going with this. I think you're starting. Did we add an intro slide?
I don't think so.
I think we forgot. We forgot to do intro slides. Sorry, introduce yourself.
Hello, I'm Asa. I'm a first year here at RIT. And yeah, this is my first presentation.
Hi guys, I'm Enzo. Nice to meet you. All right. Oh, also plug. I'm gonna do a couple more of these co-presentations. So if you're a freshman, hit me up.
Okay, starting off with some basic definitions. What is a man-in-the-middle attack? The classic example of a man-in-the-middle attack is unsecured Wi-Fi. Someone logs on, says, "Hello everyone, I am now the router. Please send all traffic to me." And then they just take your key and take the key of the server, and they take your key, and then they give you and the server you're trying to talk to their key, and then they can decrypt everything and slurp out all your internet goodness. Also, what is Active Directory? Active Directory is a Windows thing for sharing information on the network. Stuff like user accounts, DNS, directory, and it has DNS as a component of that for locating machines on the network.
So I'm going to go over some basic Windows authentication terms because that's sort of what we're attacking in this presentation. So NTLM stands for NT, New Technology LAN Manager. Thank you, Windows. Very cool. And the basic gist of how it works is this diagram right here. So your passwords, when you enter a password into Windows, that password is entered into a hashing algorithm. So it's a one-way thing that can't really be broken, technically. So you're not sending your passwords over the network. You're only sending, I guess, hashes. But in this case, we're not even sending them over the network, which I'm going to get into. So how it works is there's this thing called a challenge, which is a 16-byte random number that is generated on the server. And then it is encrypted with your hash that is stored on the server. So when you enter in a password on one side, you receive that challenge. You hash the password that you gave and then encrypt that. And then if the two challenges match, you have authenticated, you're good. So that's just Windows' way of not sending passwords or live hashes over the network. Another key term that we're going to use is called net NTLM. So if you can see this thing right there called the NTLM response, it is in the same format of an NTLM hash, but it is not actually the password hash. This is that challenge that has been encrypted with the NTLM. It's the random number that's been hashed and encrypted with the hash. So that is not actually a password hash. That is a response. So this goes into the next point, which we're going to use later, is an attack called pass the hash, not pass the pass. So basically, if you are on Windows and you are able to dump the actual NTLM v2 hashes on Windows, you know, tools like Mimikatz, which I went over in my Windows presentation, you can trick the authentication system on Windows into just passing it the hash, and then it compares the two hashes, and if it's good, then you authenticate on Windows. So you're using the hash, and you don't actually need to get passwords on Windows. Oops, wrong thing.
Okay. In the event that Active Directory, the DNS for Active Directory cannot find a file server, the client machine will use a protocol called LLMNR, which stands for Local Link Multicast Name Resolution. It's basically the client computer goes around and it starts just asking random machines, hello, are you this machine, whatever it's trying to get to. So this can be, oh wait, that's the next slide, never mind. So this can be exploited. If you're an attacker, you can just say yes. Whatever they ask for, you just say, yes, that is me, hello, please log in. And so then they send you your, the client sends the net NTLM hash, which we can use later. And you already talked about NTLM net hashes.
Oh gosh. Okay, so this part, that's you, and then I'll talk about the chart.
So here are some different auto discovery protocols, SMB, LDAP, and MS SQL, and HTTP all have auto discovery features which can be exploited.
So those are the main ones right there. Those are the main ones. There's also DHCP, which is relatively new. The tool that we're going to use, you have to pay to use the DHCP. It's dumb. Anyway, and then Smash, you had one that you mentioned to me last night, and I'm blanking on it. SCF file. Okay. Yeah. So you can ask him about that because he knows more than me, I guess. And then the chart here, this is just a general overview chart of configurations that you'll need if you're trying to do an attack like this. So if you have, SMB1 enabled, then you can do it the entire way. SMB v2. However, when you start requiring signing and even enabling it, things start to get iffy and the attack might not be possible. So by default on a domain controller, SMB, and a bunch of these other protocols, signing is enabled. So it's harder to do, whereas on a Windows 10 home client, whatever machine, it's not enabled by default, so it's easier to do. It's just a couple registry keys if you want to change that. Touchy mic. I think this is me. Yes. Okay, so what sort of tools can we use to abuse this technology? So the first one is the biggest one, and if any of you are into pen testing, you've probably heard of this one. This one's called Responder. So Responder is a poisoner for all of these multicast protocols. It has built-in authentication servers for every type of protocol that we mentioned, and it's all completely written in Python, so that's it. Another big one is Impact's NTLM Relay X. So we will be using this alongside Responder to relay its traffic, which I will be going into later. And we will use this to dump the hashes, the actual hashes on the machine. More on that later in the demo. And then we're going to also use Impact's PSExec, which is Python as well. So we'll be using that for remote code execution. And can use that with pass the hash, which we're going to use there. So next slide. Oh, this is also me. Okay. So this is how to set up Responder in a most basic format right here. So you must run as root, so you need to use sudo, run python 3 responder.py, and then you have to give it an interface name. So you're giving it a network adapter. It will listen for all traffic on that adapter. There's a whole, oh my God, there's a whole bunch of options right here. You can all look into that if you want to test this tool out. This image down here is the net NTLM hashes that were dumped on a basic, just listen on Responder and see what traffic we can find. So these were the responses that we caught for the administrator account. So we now know that there's an administrator account on there. So next slide. So what is relaying? So basically, this is a bit more elaborate than man in the middle, but you're sending back and forth the information from client to server. That's normal. The server will believe that the attacker has authenticated, and then it will give that attacker the context of that user account, and then they can execute commands or programs on behalf of the tricked account. So you're basically relaying all the traffic, and then you can run commands as that user. Is this also me? Oh my God. So setting up these two programs in conjunction with each other, there's one file you have to change. There's a responder.com config file. You turn off SMB and HTTP on responder because we're going to use that in NTLM Relay X. So basically how the thing will work is you'll relay authentication and then you'll impersonate the account that is requesting access to our fake file share or whatever we're using, and then we will use that to remote execute commands. So by default, we will have NTLM Relay X running secrets dump, which will dump the actual hashes, and then we can use that for pass the hash. You can set commands, payloads, anything that you want to do with this, you can do. So that's up to you.
Okay, so how do you stop us from doing this to you? First, easiest way, just turn off LLMNR. You can't exploit it if it's not enabled. You can also switch from NTLM to Kerberos for network authentication. That requires a third party to basically say, yes, this is okay, I approve of this. So you can't just grab the hashes from them. Also just relay attack mitigations requiring signing, and then just run an antivirus, which will stop us from dumping the actual NTLM hashes if we get a net NTLM hash. Okay, now time for a demo.
Let me get set up. If you want to clip that onto your shirt so you can. The 3 VM strat.
Can Mac handle it?
It'll have to.
You will never be trifling.
It's just on the thing. God, this thing is pissed.
What about it, bro?
All right. Oh, I'm not used to wearing a mic. Okay, let's start by booting up responder. I have to sudo it. That's not how you spell sudo.
Oh, for context too, the Windows machine on the left, if you want to do this one right on the left is our one machine, the one that we're not going to be targeting, and then the black one up there, that's the machine we're going to be targeting. So we'll be pretending that this one, the one with the Windows logo, that's the one we've social engineered to reach out to the server.
So we'll just start responder here. Oh, is it kind time? Oh, I can't spell.
Oh.
Okay, there it goes. And then boot up.
Control B down there.
Boot up.
NTLM.
Yeah. Just. Oh, okay, there we go. Start NTLM Relay X and give it our target. Uh, 183.6.
And SMB2 support. What did you get? SMB2 support.
Oh, I see.
Yep. NTLM relay.py. Get that back arrow key. Yeah. Thank you.
Yeah, there we go.
Oh,
Oh,
uh-oh.
address already in use. Well, that's fun.
Oh, the demo gods. Oh, I know what it is. Ah, yes.
Oh, that would be the issue.
So you have to turn this off. I forgot to turn it off. All right, so now we're listening for traffic in order to abuse this technique.
Okay, so now if we just look for something that doesn't exist,
No. Two words.
let's just look for Rick Astley. So now if we come over to our responder, it just poisoned the LLMNR. And so here's a hash.
And these are the actual hashes.
Oh, really? Okay.
Yeah, so if we had done just responder on the top window, it would have just dumped the net NTLM hashes. But since we were relaying with NTLM Relay X, we were able to run secret stump as the administrator users and get the actual hashes. So we're going to use those hashes in a pass the hash attack now to Control C.
Okay. So now let's just log on to the Windows machine. That's not how you spell Python.
Yes, exactly. This thing's angry at you.
Yes.
Just do a...
Grab the hash.
What to the D?
All right, it's a Mac.
I should have copied.
Okay.
It's Control Shift V to paste.
Okay.
Or you can go up in the arrow keys, command history if you want to do that. Cut recommend shift. Or sorry, control. This one, the other one. Control shift. No, YouTube video. How is this not copying? Technical difficulty.
Okay, so I just don't know how to copy things on a Mac. And then our target IP.
Oh yeah, you spelled administrator wrong.
Oh, that does definitely sound like something I would do. Administrator.
Administrator.
Oh, I still spelled it wrong.
It's spelled correctly on the Windows machine. Just give that
Yay. Okay. So now this is a terminal window that's running on our target. So does anyone have a file that they want me to, or I guess just a text string that they want me to put on the server?
Joe Biden.
Joe Biden.
You gotta give it something.
Okay. What did we want to echo it in?
You can't go back. There's no back arrow. So that's cool.
Rick, okay. Into,
The colon goes before the slash. We love Windows, right, guys?
Oh yeah.
Yeah.
it's also, I always try to LS in Windows, it's very fun.
Not as much as he loves.
Okay. So now if we just come in here,
Oh.
oh,
Y'all seen that Rick and Morty season 5 finale, bro? Nope. It was kind of trash, low key. I didn't see it, so I don't know. God damn it.
and then,
Oh, is it not there? There it is. Rick.
hey, it's there.
Coming back. Actually, let's shut all these down. Oops. All right. Oop. What in the world? Okay, so here are some resources that we'll post the slides, don't worry about it. There's a lot more that you can do with this, and you can attack other protocols like we said. This was just the most classic SMB impersonation name resolution attack. It's really up to you guys if you want to go more into it and that sort of thing. So does anybody have any questions? Nothing? Cool. All right, thank you guys very much.